In the next lesson, we'll be looking at arithmetic sequence. Today, I'll be breaking down the details of sequency and series for grade 12. Our first lesson will be based on the introduction of what a sequency is. A sequency is defined as a list of ordered numbers. Now, what I mean by this, I will use an example. Say, for instance, we have a list of numbers such as 2, 4, 6, and the numbers, they go on like that, growing. So these dotted lines mean these numbers are going on. We'll have an 8 after the 6, the 10 after the 8, and so on. Now, these numbers, the first thing that we have to see is that they are a list of numbers. I'm listing numbers here. But these numbers, we say they are ordered. When we say they are ordered, what we mean by that is that they are ordered from the first position, what we call T1, to the second position T2, the third position T3, and this will continue just like that to T4, T5, T6, as these numbers continue going like that. That is the order that we have in these numbers. Now, this is to say that we cannot have these numbers to be sitting like a 4, a 2, and a 6 going like that, because what that would mean is that we will now have position 2 being the first one, position 1 being the second one. Okay, here we still have the position 3. There is no order here. These numbers are just random. So these numbers have to be an ordered list. They cannot be random. But we then have to look at what T1, T2, and T3 means. So T1 means that it is the first term, what we call term number 1. In other words, T1 represents the number in the first position. So that is to say that I can say T1 is equals to the number 2. They are the same because they represent, T1 represents the number in the first position. T2 would be the second term, what we call term 2. And this means that T2 will be equal to 4 in my example because it represents the number in the second position. And this will go on like, it will continue going on like that. We will still have the third term, which will be T3, and is going to be given by 6. And this will go on like that. Now, if we continue growing these numbers, we get to a point where we then have what we call Tn. Now, the Tn would mean the nth term. Tn would mean the nth term. The n it represents the number of terms. So n would be the number of terms. So it tells us which term we are dealing with, right? That means already it assists us to count or to position these terms. So it is only allowed to be an element of natural numbers. Remember, the natural numbers are the counting numbers. So this means that we're going to have 1, 2, 3, 4, and so on. So n is allowed to be any of the counting numbers. It can be 1, 2, 3, 4, and so on. Now, this means n represents any number in the sequence. For example, if let's say n is equals to 1, this would mean that we are going to have our Tn. I'm starting with this Tn, right? Then we're going to put a 1 in a place of n so that I have T1. What I've done is that I've substituted the 1 in place of n because I'm saying n is equals to 1. Then I get term 1, right? The first term. If n is equals to a 2, then I'm going to have Tn to be given by T2. Again, I just took n and replaced it by 2 because I'm saying n is equals to 2. I can continue doing this maybe up until, let's say, n is 10 for an instance. Now, this means I'm going to have Tn is equals to T10 because now I'm replacing the n with a 10 because I'm saying I'm looking at term 2. You know, I can continue doing this maybe up until some point where I say n is equals to 100, so that now I have Tn is equals to T100. Again, I'm just replacing the n here with 100 because I'm saying n is equals to 100. Now, in that sense, we are saying that Tn represents any number in the sequence. We are saying that this Tn represents any number in the sequence. It actually represents any term in the sequence. It can be any number in the sequence, and it's only allowed to be natural numbers, the counting numbers. I want to look at a sequence from a different perspective. Say we then have term 1, and I want to grow these terms so that I have the next term. What I'll do here is that I'll take the 1 and add a 1. So this means I'm taking this 1 here and I add a 1. Right, so I'm taking this 1 and I'm adding 1. My answer here would be a 2. This means that my second term would then be T2. Right, so I was able to move from T1 to T2 by adding a 1 so that I get this 2 here. We call this the previous term because it comes before this term here. So it's the previous term, and we call this the next term. But again, I can continue actually increasing these sequences so that now I have the next term that's coming after T2. So that means I can take the 2, I can take this 2 and add 1 on it so that I have a 2 plus 1, and this gives me a 3. Now this means I'm going to have T3. And you know, I can continue doing this. I can add a 1 again on a 3, I'm going to have T4. Then I can add a 1 on a 4, I'm going to have T5. And I'll continue doing this as I'm growing this sequence. So you have to be able to see that pattern to say to get to the next term, we actually add 1, you know, because then this will be the previous term and the next term, right? And then to get to the next term here, I've added 1 on a 2, so that T3 is the next term of T2. And actually T2 is the previous term of T3. We know that if we continue doing this, we just discussed that we'll get to a point where we have Tn, meaning any term in the sequence, right? It represents any term in the sequence. It's a general way of expressing any of these terms here and any of the coming terms in the sequence. Using the same logic that we applied to get from the previous term to the next term, if I were to look at the term that comes after Tn, meaning the next term here, I will then actually take the n and add 1. I should be able to get to the next term because that's how we've been building from the previous term to the next term in this sequence. So this means that then now I'm going to have here a Tn plus 1. And this maybe may continue like that. It is then important to notice that in this arrangement here, we will call this the previous term and call this the next term. And this can be actually a general way of representing the previous term and the next term. So what I'm saying is that I can conclude to say, look, in general, when you have Tn, another way of looking at it, you can say it is the previous term and Tn plus 1 is actually the next term. So say, for example, we have n is equals to 1. This would mean that I'll take my Tn, the nth term, which in this case I'm viewing it from the perspective that it is the previous term, right? I'm going to have the Tn to be equal to, because now I'm saying n is equals to 1, I'm going to substitute the 1 there so that I actually now have n is equals to 1. But you have to understand that if you take the Tn plus 1, we are now going to have 1 plus 1 because we are saying that n here is equal to 1. And this will actually give me T2. Now let's have a look at these two terms. We're saying here we have T1 and we're saying here we have T2. It means this is the previous term and this is the next term, because remember, T1 comes before T2. We can extend this example by looking at other values of n. Let's say n is equals to 2. Remember, n is allowed to be any of the natural numbers. I can take a 2 for instance, so that now I'm going to have Tn is equals to T2, right? In other words, when n is equals to 2, I'm actually looking at the second term. But when I take the Tn plus 1, I'm actually going to have 2 plus 1 at the bottom, because we are saying that n is equals to 2. And this will simplify actually to 2 to t is equals to T3 is going to simplify to 2 to T3, so that when you add a 2 and a 1, you get a 3. But if you look at these two, you would see that T2 comes before T3. That means this is going to be the previous term and this will be the next term after T2. And you can continue doing this by trying any of the numbers of n, because n is allowed to be any natural numbers. You can take maybe a 5. Let me do it just to emphasize the point, to say if we then have T5, we're actually going to have Tn is equals to 5. That means we are dealing with term 5 because our n is equals to 5. But in terms of looking at it from Tn plus 1, we're actually going to have Tn, we're going to have a 5 plus 1, and this will give us a T6. Now again, the T5, is the 5th position and the T6 the 6th position. T5 comes before T6, so T5 would be the previous term and this will be the next term after T5. So this is to say that when you see Tn, you can look at it from a perspective that it is the previous term, and when you see Tn plus 1, you can look at it from the perspective that it is the next term. It comes after Tn. There are two types of sequences that we're going to study in grade 12. The first one is called an infinite sequence. Now, this is a sequence that is non-terminating. To say something is non-terminating, it means that it does not end. Non-terminating would mean it does not end. It goes on until infinity. You know, the word infinite comes from infinity. So this means that if I were to have term 1, I'll also have term 2, I'll also have term 3, and we use these 3 dots at the end to say it will continue to term 4, term 5, term 6, term 7, term 8, term 9, term 10, and so on until infinity. So this sequence doesn't end. If someone writes a list of numbers, a list of ordered numbers, such that there's these 3 dots at the end, it means it does not end, and we call that an infinite series. Sequence, I mean to say. We also have a finite sequence. So this will be a terminating sequence. So this is a sequence that actually ends. To say it's terminating, it means that it ends at some point. So this would be something that looks like T1, T2, T3, T4, T5. I've written a 4 there, it should be a 5, and it ends exactly there. If you look at this, there is no dotted lines here after the 5. It means this sequence actually starts exactly at position 1, term 1, and it ends at position 5, term 5. And then we call that a finite series. It actually ends, it is terminating. So I can use my numbers that I've used there at the top as examples to say here I can have 2, 4, 6, and if I write the 3 dotted lines there, it means they'll go on without terminating until infinity. But here I can have a 2, 4, 6, 8, and a 10. So this sequence ends exactly at 10, which is position 5, T5. With this introduction, we'll be in a position where we can study different types of sequences, because you can see that we'll have a lot of sequences that comes from this background. However, in grade 12, we only do 3 types of sequences: arithmetic sequence, geometric sequence, and quadratic sequence. In the next lesson, we'll be looking at arithmetic sequence.